Hello, this is a presentation by AMS Consulting on the assessment of a rooftop solar hydrogen system for Douglas Elliman Real Estate. Douglas Elliman is the second largest real estate firm in the United States, with almost $30 billion in sales last year. The company recognizes the need for green energy practices and has asked us to evaluate the technical and economic viability of a rooftop system at one of their apartment complexes in New York City. There is a large amount of energy in sunlight which can be captured using fast-improving solar and electrolysis technology to produce cheap electricity, especially with rapidly decreasing costs for such technology. We can then use this energy to produce hydrogen through the electrolyzer, making a solar fuel that can be converted back to electricity using fuel cells. The left side of this slide illustrates the process flow diagram of the designated solar energy system for Elliman. Green boxes designate main system components, orange existing components, and gray areas for intermediate steps. Photons from sunlight are absorbed into the monocrystalline silicon wafers of the solar panels on the roof of the building, generating electricity which then flow through an inverter. That electrical energy can either be used by the building or pass through the proton exchange membrane or PEM electrolyzer with water from the building's existing tank. The electrolyzer will form oxygen, which is then vented to the atmosphere, and hydrogen, which is stored in a hydrogen tank. When required, that hydrogen can be passed through a PEM fuel cell with oxygen from the air to generate electricity for the building, along with water and heat. The reactions for splitting water by the electrolyzer and formation are given on the right. Here is a more detailed view of the PEM electrolyzer and PEM fuel cell systems. These are the specifications mentioned for the PV panels, electrolyzer, fuel cell, and hydrogen storage tank. The layout of the PV panels is illustrated on this slide, with the purple rectangles on the roof being the panels. For the design of the system, the building rooftop is able to fit 204 PV modules because we also had to account for walkway space and avoid wasting modules on heavily shaded areas. Table 6 lists the components and the costs needed for the system with the total of $173,952 before incentives. From our technical analysis of the system, we determined that PV panels would generate 59.1 megawatt hours of energy per year, based on a PV efficiency of 19%, incident light loss of 10%, and 20% overall system loss. This value is very small compared to the building's electricity demand of 1,144.8 megawatt hours per year, based on the assumption that the average apartment uses 10.8 megawatt hours per year. We also determined that 1,117 kilograms of hydrogen could be produced if all the energy generated by the PV panels were diverted into the electrolyzer. That amount of hydrogen could generate 22.2 megawatt hours of energy per year when passed through the fuel cell system, assuming that the fuel cell has an efficiency of 50%. The solar to hydrogen efficiency was evaluated to be 14.25%, while the round-trip efficiency was found to be 37.5%. After performing the techno-economic analysis based on the provided assumptions in Table 10, we determined the total life cycle cost to be $151,338 and a levelized cost of energy to be 14 cents per kilowatt hour. According to our discounted cash flow model, our payback time is approximately 6.5 years to recoup the investment of the PV system. In conclusion, we suggest Douglas Elliman Real Estate to proceed only with the PV panel system. The electricity produced from the hydrogen conversion accounts for less than 2% of the energy needs of the building, while the PV panel's electricity accounts for 5%. Using our design, the solar panel system can completely power about 5 apartments per year. Additionally, the inclusion of solar technology to a property can increase its value by 3%. At a minimum, selling 5 apartments with this increased value could cover the cost of the entire solar panel system and could incentivize prospective buyers with the perk of free electricity over the system's lifespan. Here are a list of our references, and thank you for your time.